starting with the name of Almighty Allah, who is most merciful and most beneficent. This is Jamil Ahmad along with my team member Taharu, and today I'm going to present our final year project, Detection of False Data Injection Attack in Smart Grid by using Kalman filter. So this project is supervised by Dr. Gulsher Ali and co-supervised by Engineer Muhammad Fawad. So our presentation flow will be project plan, then introduction and background, then motivation, then problem statement and solution, aims and objectives, literature review, methodology, project outlook, results and discussion, conclusion, future recommendation, then references. So this was our project plan. We had gone through some literature review, then analysis of proposed scheme. Then we came in implementation of the scheme or model. Then we did analysis and simulation. Finally, we went for final write-up and thesis submission. So introduction and background. Basically, the complex nature of traditional power grid, together with the ever-increasing demand for electricity, creates the need for efficient analysis and control of the power system. The smart grid is more advanced and modernized way of transmitting power that is preferably suitable for the 21st century. Traditional grid basically that has basically one-way communication. When we talk about smart grid, it is basically two-way communication. The complete circuitry, that could communicate with each other. If any fault is coming, we could know basically that where that fault is, and basically the whole grid basically knows how much power basically using are gonna be used in what place or where. So what was the motivation behind this project? So motivation was behind this project was like currently we don't have smart grids in our country, in Pakistan, though it is in other developing countries. But in future, if we are gonna having a smart grid in our country, then obviously there will be threats, security threats. So this smart grid is basically backbone of all infrastructure. So that's why we choose this project, so that we could secure the smart grids. By securing the smart grids, we will ultimately will be saving energy, and so we will be saving cost. And the main thing, reliability will be maintained if due to any unplanned situation, and any unplanned situation, the whole smart grid is gonna shut down, then the reliability will not be maintained, and that will be huge loss basically. Okay, so coming towards problem statement. Basically, as I mentioned that this smart grid is basically this involves internet. So when there is involvement of internet anywhere, there is possibility of attacks by hackers. So same here, due to involvement of internet in our smart grids, there are possibilities of attacks. That attack is in the form of injection of false data in our case. That could be in different forms in smart grids. Okay. So basically, our solution is we have basically used Kalman filter, and we will be detecting the false data injection by using this Kalman filter in smart grids. There are two types of attacks: minor attacks and major attacks. Minor attacks basically are done by consumers, that is manipulation by consumer. That is on minor level, but the attacks that we are concerned, basically those are external attacks. We call them major attacks, that are from attackers or hackers via using internet directly in the controllers, on the controller of the systems. Aims and objectives our project are, we basically have to do analysis of Kalman filter, that we did analysis of Kalman filter, and application of Kalman filter to smart grid, then basically comparison of actual data and false data using detection technique in MATLAB or Simulink. So literature review, we have gone through many research papers. As power grid is one of the important infrastructure backbones, as I mentioned, having a deep impact on economy as well as our daily activities. So if basically power grid fails, it could have catastrophic effects, as basically in past happens according to the literature review in New York in 2003, also in Mumbai in 2012. And those both failures in power grids were there due to the faults in the systems. So, okay. Coming towards basically Kalman filter. Kalman filter is basically named after Rudolf E. Kalman. This Kalman filter was basically first time implemented by NASA in 1960. Kalman filter is basically it is an optimal estimation algorithm. Optimal estimation means the variable of interest can only be measured indirectly. Means there is if there is anything that we cannot measure directly, then we can use Kalman filter to measure that variable indirectly. This basically used to estimate the system state when it cannot measure directly, as I told earlier. So there are some common applications for Kalman filter that are guidance and navigation systems, computer vision systems, and signal processing. So one of the very first applications of the Kalman filter was the Apollo project, as I told, and it was used by NASA in 1960. It was basically for Apollo project. Coming towards that Apollo project, what was that? Basically, as I told, that the Kalman filter is used to measure something that we cannot measure directly. So in Apollo project, basically they had to measure the internal temperature of the rocket so that they could know that how much temperature they should maintain to launch the rocket. So there are T external and T internal. T external is available for measurement. External temperature that is available for measurement, we can measure it. But internal temperature T in, that is not available for measurement. Internal temperature we cannot measure directly. Basically, there is a huge amount of heat. If we are gonna place sensors over there, obviously those could get melt. So we cannot measure the internal temperature. That's why T in is not available for measurement. But here is another option. We can measure external temperature of this rocket. So basically, Kalman filter here in Apollo project was used to find the best estimate of the internal temperature in the example as of rocket, because internal temperature is not measurable directly there. So we use Kalman filter from an indirect measurement. That's all what I explained. So methodology for our project. So basically, firstly, we implemented the smart grid in smart grid system in simulation. Then basically we studied about the Kalman filter and we designed Kalman filter in simulation. And after that, we basically tried to cascade Kalman filter and Kalman filter and smart grid systems. And we inject the false data in the smart grid system on their controller manually. And then we detected that false data injection by using Kalman filter. So why basically we used Kalman filter? There are many other filters like adaptive filter. Why basically we prefer this Kalman filter? As I told that Kalman filter is a filter that basically helps to measure indirect variables. So same as in smart grid, we cannot detect the injection of false data directly. So that's why basically we used and we preferred Kalman filter, due to which actually we can detect the FDI, it means false data injection attacks, by comparing the existing data with the real-time data as per our objective, as this is our objective. Okay. Also, basically, this is very simpler to implement, and it is quick responsive model. It is implementable to vast applications. So this is the project outlook of our whole project. This is in MATLAB or simulation. So I'm gonna internal. I'm gonna let you know people what is basically this internal circuitry is. So there is basically smart grid system, and then Kalman filter. Smart grid system is basically cascaded with the Kalman filter, and smart grid systems, their VSC controller. Okay, there is a PV array and utility grid. MPPT is used with PV array, and basically there is a load. Okay, so basically, how we are basically manipulating the voltage in VSC controller manually. We are considering this as a take, external attack, right? So moving ahead, as I told that the reference or default value for a smart grid was we kept 500 volt. That was for the normal operating conditions. But after that, we basically manipulated the voltage in controller, VSC controller. We took different, basically analyzed with different values of voltage. Like for a take 1, it was 700. For a take 2, it was 800. For a take 3, it was 900. For a take 4, it was 1000. For a take 5, it was 1100. Then for a take 6, it was 1200. Finally, for a take 7, it was 1500. So on different, basically different values of voltage, we took results and analyzed it. Okay, so this is the internal structure of the utility grid, as you people have seen previously the utility grid. So it is the internal structure of that. This is the basically Kalman filter, and Kalman filter. It is the internal structure of Kalman filter. Basically, the reference is coming from the directly from the smart grid. It is coming the live data that the voltage we are changing. That change in voltage basically coming here in the form of reference, and that is directly going to the input of the Kalman filter. We also added process noise and sensor noise here. Okay. So basically, moving towards results and discussion. Basically, as the attack that an attacker could, done in the smart grid system, that could be in the either in changing in the voltage or current, or it could also be in the angle between the voltage and the current. Basically, the attacker will be attacking on any bus that could he or she will be changing the bus voltage, as people can show in the can see in this picture. So this is the Kalman filter response that we had got. That has actual voltages and also filtered output from Kalman filter. Actual voltages are the reference voltages that are coming from the grid, and filter output is the output of the Kalman filter, basically. Conclusion. So basically, a detection of false data injection attack at smart grid will protect our system from unwanted power outages, consumption of electricity, and it will save economy. Also, the reliability of the electricity will be maintained. So theft detection becomes easy. We can detect the theft of the electricity very easily by this project. So future recommendation are we will be working on more accuracy of the results, and currently we just worked on the detection of false data injection in the smart grid. We haven't gone with the prevention. So after detection in future, we can go with any immediate alarm generation and immediate action after detection of that false data. So in future we can go for prevention of smart grids. And by using basically any technique of the detection. So these are the references that we basically used for our project. Thank you so much. If you have any questions regarding our project, if you want to know more about this project, so you may contact us on the mentioned email, and if hopefully we shall be helping you people to resolve or answering that question. Thank you so much.